Hello again. My name is Kelly. I'll be your moderator for this session. Quick reminder that we will have time for a brief live Q&A after the presentation. So be sure to use the Q&A section for the chat feature. And now it's time to welcome Pu Chang with Pinterest and Jerry with Data Strio to the stage for their session, Scaling Iceberg Adoption at Pinterest with Gravitino. Go ahead, guys.
Hi, everyone. My name is Pu Chen. I'm from Pinterest. So today, Jerry and I will be presenting scaling Iceberg adoption at Pinterest with Gravitino. A little bit about myself. My name is Pu Chen. I'm from Pinterest. Pinterest is a visual discovery engine for finding ideas like recipes, home and style inspiration, and more. I'm a senior software engineer at Pinterest. I'm working on data lake, catalog services, and also the surrounding big data processing engines like Spark, Trino, and Flink. I'm a contributor for Trino and Apache Iceberg project and also Apache Gravitino project.
Hi, my name is Jerry, and I'm the co-founder and CTO of Data Strio. I'm the originator of Apache Gravitino. Also, I'm the PMC member of the Apache Spark and Apache member. And I've been working on the big data area for more than 10 years. My past experience include like Tencent, Hortonworks, Intel. And for our company Data Strio is aim to build a unified catalog for the data and AI governance.
Okay, with that, first I will walk you through the agenda today, and then we'll dive into each section later on. First, I will talk about Pinterest Iceberg usage, about its overview and challenges. Later, I will specifically talk about how Pinterest leverage IRC to solve Pinterest challenges. And then next, Jerry will walk us through the Apache Gravitino and Gravitino IRC. Then going back to myself, I will mostly talk about Gravitino IRC adoption and Pinterest. And lastly, we both will share the future plan of our development. Let's dive into the Pinterest Iceberg usage overview. So first, Pinterest started Iceberg adoption from 2022, and then we are growing since then. In the past few years, so our Iceberg adoption are majorly driven by user opt-in and self-serve migration. There are also platform teams driven migration for really high ROI use cases. And then this year and in the future, we are thinking about making Iceberg as a default table format to further scale the Iceberg adoption. Here are some numbers by Iceberg usage at Pinterest. We have about 8,000 Iceberg tables. 50% of them are production tables. And we have about 80,000 of Hive table, and more than 0.5% of them are for production. We have 130 petabyte of data for Iceberg table, and it is 1/5 of the size of the Hive table, which is about 600 and 500 petabytes. For all the Iceberg table, they are all Parquet with Z-standard compression. And for Hive, this number varies. We have about 60% of Parquet table, and remaining are other file formats such as sequence file and text file. For Iceberg table, majority of the Hive table, Iceberg table are in V1 tables, and we have limited use cases for V2 tables as well. Then let me share about the Pinterest Iceberg architecture. So as you can see on the top side, which is the engine layer. So we are supporting Spark, Trino, Flink, Ray, and some Iceberg library backed by PyIceberg for metadata read operations. So the engines would use the Iceberg REST catalog as a catalog implementation, and then which is backed by the Hive Metastore. And on the storage side, we are using S3 to store our data and metadata. On the bottom is our table governance. We have a table garbage collection, partition retention, table maintenance, and table governance to make sure that the table are in healthy state and the user can focus on the work they are for their business, to not worry about the table healthiness. Here are some Pinterest Iceberg usage by use cases. we have from the real-time to offline. First, we have streaming ingestion, leveraging Kafka and Flink. We also have online database near real-time replication using from MySQL, TiDB, and KV storage to the offline via Debezium, Kafka, Flink, and Iceberg. We also have low-level user data deletion for user and advertisers. And we have machine learning related use cases for ML training, ETL feature backfills. In these use cases, we leverage bucket join for Iceberg table, white table feature backfills. This table have more than 3,000 columns. And we also leveraging Ray and V1 table, Iceberg and PyArrow along the way. Besides that, we also have the traditional ETL use cases such as reporting and dashboarding. Here are some challenges of Pinterest Iceberg usage. First, what we see is the partition is listening very slow. The major reason is in comparison to the Hive table, the partition is actually not treated as the first-class citizen. So in order to get the partition information, we need to scan all the metadata and do some runtime aggregation. Also, we are lacking of easy-to-use tools for performance monitoring, such as data read and write. Lastly, so for engine-specific performance issue, such as query engine planning time too long, filter not pushed out in time, so we are lacking of enough tooling to monitor the performance to make sure the system are running fast and efficient. For the usability front, we are lacking of a table governance that enforce what table location and property a user can set. And we are also lacking of a centralized place for such enforcement. So in order to do that, before leveraging the Iceberg REST catalog, we actually implement those table governance on the client side. This making a platform that support multiple engines very difficult. Also, there's lots of hassle to integrate with high meta store service directly. For example, we need to have a Kerberos support, and then we also need the Iceberg specific connector to talk to high meta store. This is not a lightweight method. And there's also a lot of hassle to integrate with S3 directly, mostly due to the access control and authorizations. When clients need to integrate with S3, so they need to integrate with the S3 policy. You make sure that it has the right permission to read to S3. It is not trivial in organization with sophisticated access control policy in place. Next, I'm going to talk about how Pinterest leverage Iceberg REST catalog solved all the challenges I just mentioned. First, regarding the performance, about partition listening slow. So what we did is we implemented a custom partition metadata for the partition. In short, every write to the table, we produce a changed partition in the snapshot metadata. We call it a delta partitions. And periodically, we materialize a partition for a given snapshot. And then during the runtime, when we're trying to calculate the final partition list, we combine the materialized partition with all the deltas after the snapshot, from the snapshot after the materialized snapshot. This reduced the time from partition listing from hours to sub 10 seconds. This improvement is huge, especially for table with 10 plus petabyte of data, 30,000 manifests, and 100 million objects in S3 table, in single S3 table, a single Iceberg table. We are in evaluation on IRC side to further improve this by caching for further speed up. At the same time, we are also paying attention closely to open source partition stats work because we think this is the right way to go. But before that, I think we are leveraging the customization to solve our pain point, to make our customer happy and earlier than before the work is delivered. On the second part, regarding lacking of easy to use tools for performance monitoring, so we are collecting. What we can do with IRC is to collect the Iceberg stacks effortless with IRC. To be specific, using the commit report, we can leverage that to have a commit notification for latency sensitive applications. We can also capture the data shape changes as part of the commit report. For the scan report, we can capture the column usage for column pruning, table sorting. We can also capture the filter usage for table sorting and storage tiering tuning as well. Further, we can monitor the planning time and scan data for query performance. Regarding the usability challenge, we previously mentioned that we are lacking of a centralized place for table governance. With IRC, we implemented table governance on the IRC so that we don't have to replicate the table governance logic on the client side to reduce the duplicate code. And the governance rules includes assigning the table location for a given Iceberg table, rejecting the table creation if it violates the policies, and also setting default table properties for the users. Additionally, by leveraging IRC, we are removing the hassle of integrating with HMS. By using IRC, all we need to do is just send an HTTP request to IRC, and that's done. So this operation can even be done via curl command. So you don't need to have any HMS client or even a Python. You don't need a Python script in order to do that. Just a curl command. So also, you remove the hassle of integrating with S3. This is because we offload the S3 integration to IRC, and then also and our internal IRC is doing all the heavy lifting of user authentication and authorization for the users. Additionally, we added a customized APIs for Pinterest specific needs. One is what we just mentioned about partition listing. We also do similar thing for check partition and guess partition last modified time. Then I'll hand it over to Jerry to talk about Apache Gravitino and Gravitino IRC.
Thanks, Kuchen, for the introduction about Iceberg adoption in the Pinterest. So now let me walk you through to the details about Apache Gravitino and the Gravitino IRC. So why do you build Apache Gravitino? Let's take a modern data-driven company as an example. So for such a company, they will typically have several different data stacks to serve for the different purpose. For example, they will have a Hadoop-based data lake for the ETL and batch processing requirements. And also they will have like a data warehouse for the ad hoc queries, ad hoc analytics. And they will have a streaming processing data stack for the streaming requirements and machine learning data stack for the machine learning requirements. As you can see, for each different scenarios, we'll introduce a different data stack. So there will an obvious problem of the data silos. So how do we handle these problems? One solution is to unify the data in one unified storage layer. For example, we can use a lakehouse technology to store all the data using one lakehouse technology. But this is still hard to serve for all the needs because current lakehouse technology cannot well support for like streaming analytics and also for the machine learning things. So it is hard to unify the data from the storage layer. So think of things that each data should have a metadata related. So instead of unifying the data together, can we unify the metadata together? Because each data stack should have a catalog to manage its own data. So instead of managing the data together, we can manage metadata together. So with this concept or with this idea, we bring out our concept, our project, Apache Gravitino. Apache Gravitino is a catalog on top of catalogs. It can manage catalogs in a unified way so that we can build a unified metadata lake. So with Gravitino, we can solve several problems. For example, we can have a big picture of the whole data, and also we can achieve single source of truth from the metadata layer, and without needing to move the data, and also we can do the centralized data governance and secure and audit in a unified way. So this is Gravitino. I put a next page. So how Gravitino achieve this thing? So here is the whole picture of the Gravitino. As you can see, the most important part Gravitino provides is a generic metadata object model. As you can see, we define the metadata model for each kind of the data. For example, like tabular data, we define a generic table metadata model, and with this, and we can represent different kinds of tables. For example, like Hive table, Iceberg table, and also like MySQL and PG tables using a unified table metadata. And also we can support like we define a file set metadata, and use the file set. We can manage the files and directories on the file systems like HDFS, S3, and others. And also we abstract a model metadata and a top metadata to manage the machine learning models and streaming topics. And this is our core part, also with our connection layer. So we can connect to the different sources, different catalogs to manage the different kind of data. For example, like tabular data, unstructured data, and other data, using the connections, using different connectors. And on the top, we have provided a unified REST APIs. So for the engines and for the users, they can query and operate on the metadata using a unified way with our provided unified APIs. And also, besides our defined unified APIs, we also define define Iceberg REST endpoints for the Iceberg's table, because we see the a vast adoption of the Iceberg, and also Iceberg REST catalog is predominant in recently. So we also support Iceberg REST APIs. And on the top, we provide a unified processing layer to connect with different query engines, and processing engines also provide a unified governing functionalities to centralize govern the data. So this is Apache Gravitino's the whole architecture. So let's move on the Gravitino Iceberg REST catalog. So how do we do how do we achieve the Iceberg REST catalog from in the Gravitino? So as we all know that like Iceberg, they already support pluggable catalogs. For example, they support Hive catalog, which is a Hive meta store, also JDBC catalog, and other catalogs like Hadoop catalog and DynamoDB catalogs. And the user can choose their own catalogs to manage the Iceberg table, and we bring this concept also into the Gravitino, and we build a REST layer on top of different catalogs, so that we can achieve a federated catalog using our REST catalogs. For example, users are using the Hive meta store, Hive catalog, and JDBC catalog. We build an Iceberg REST catalog on top of them. They can easily move to the Iceberg REST catalog, and this Iceberg REST catalog will delegate the catalog operations to this backend catalog. So with this with this movement from the pluggable catalog to the REST catalog, we can provide a unified way with our Iceberg REST catalog to support different pluggable catalogs. And this is how we do the Iceberg REST catalog. So, as I mentioned previously, we provided two REST APIs. One is Gravitino unified REST APIs. Another is Iceberg REST APIs that follows Iceberg spec. And with these two APIs, we can both operate on the same table. For example, we can, if there is Iceberg table that is managed by Hive meta store, and this Hive meta store can be registered as a catalog with Gravitino unified REST API. Then we can manage this Iceberg table using our own unified REST APIs through the catalog schema, table namespace, and with our provided Gravitino Spark connector, they can also be used by Spark. And also we achieved the Iceberg REST APIs with Iceberg supported namespace and a table, and also Iceberg provided a client. It can be also used by different engines. So these two endpoints that are shareable, so that the operation on the one endpoint can also be affected by the other endpoint. User can choose either to manipulate the Iceberg table. And besides, we have provided some of the extended functionalities so that you can use our Gravitino unified REST APIs to operate on the Iceberg table, like tagging, like others. And for the Iceberg specific functionalities like namespace, like a snapshot and others, you can use Iceberg client. Push on next page. Yeah, and so compared to a basic or a reference implementation of the Iceberg REST catalog in Iceberg, so what we do is that we add a lot of functionalities in the for the production ready for the production usage. For example, the first thing is that we want to introduce is our enhanced serviceability and extensibility. And we add a metric system, also an audit system for the Iceberg REST catalog. So you can use promise use or use Grafana logi to scribe the Iceberg metrics, to collect the Iceberg REST catalog audit logs, and so that you can leverage Iceberg REST catalog and with different monitoring and logging system to do a centralized governance. And also, our Iceberg REST catalog, as I mentioned before, we achieved like a federated catalog, and with different catalog backend. Currently, we support Hive and JDBC catalog backend. We can also achieve like S3 catalog or Polaris catalog. So users they don't have large migration overhead. They can easily put our Iceberg REST catalog on top of existing catalog to migrate to the Iceberg REST catalog. And also we define a lot of events, so users can inject their own codes for the pre-event and post-event to add their customized logic. And last but not least, we also provide a flexible deployment. And if you want to use the Iceberg REST catalog endpoint and also with the Gravitino unified REST endpoint in one server, then we can deploy one system in one process. And if you want to separate into two different servers, for example, if you only want to use Iceberg REST catalog, or if you only want to use the Gravitino unified REST APIs, then you can run either and with separate processes. Put on next page. So besides of serviceability and extensibility, we also add a lot of security and access control related functionalities because it is very important to the production ready use. The first thing is about end-to-end authentication support. And our Gravitino Iceberg REST catalog provide different authentication methods. Currently, we already provide OAuth 2 and Kerberos Spinagle support. And we also have a pluggable authentication framework, so user can plug in with customized or different authentication method to achieve the authentication. And our REST catalog connect to the different catalog backend. We also support like authentication methods. For example, if the backend catalog is a Hive catalog, we can support Kerberos and delegation token with impersonation support. And JDBC, we can support user and password. And for different catalogs, we can support different authentications. And this is for metadata. And we also added the authentications for the data in the data layer. And for example, if the data is on HDFS, and we can support Kerberos and delegation token for HDFS. And for the cloud storages, we already support credential bindings. So Iceberg REST catalog can get a token for the users and pass the token to the client side, and query engines or clients can use these generated tokens to talk with as different cloud storages. That is end-to-end authentication support. Put the next page. And we also support role-based access control authorizations with our Gravitino unified REST APIs. We define a generic RBAC model, so users can add users or group to the Gravitino with our API, and also can create roles and with different privileges on different entities, and bind the role to the users. And with our unified authorization REST APIs, and these different policies will enforce in Gravitino. And when user queries the tables, they can Gravitino will enforce the policies and to check if user has the permission to read or write the tables with the access control mechanisms. Yeah, put the next page. And also we extend the Gravitino Iceberg REST catalog to support different governance functionalities like data discovery and lineage, because our Gravitino APIs support like tagging API and search API and lineage API. So we can tag on the different entities to do the data classification, and we support like to put the metadata into the search systems like OpenSearch, and provide an API so user can search with random keywords. And we also expose the lineage endpoints, so user with their operation on the Iceberg table can have a lineage information post to the Gravitino, and Gravitino will show the lineages. So this is the governance functionalities. And with all these things, Gravitino provide a enhanced Iceberg REST catalog functionalities and to the users.
Okay, thanks, Jerry, for introducing the Gravitino and Gravitino IRC. Now let me share how we adopt Gravitino IRC at Pinterest. So currently, Pinterest is running Gravitino IRC using the 0.7 branch. So on top of that, we have a customized API endpoint for check partition, list partition, as we previously mentioned. We also leverage Gravitino Event Listener for table governance. Then we also have a customization on the IRC request rewrite for table governance purpose. We have a work in progress issues in the feature ticket in the Gravitino community. So right now, almost all the engines of Spark, Trino, and Flink are onboarded to the IRC right now. I think the overall transition experience is pretty smooth, thanks to the open Iceberg REST catalog spec, the solid implementation of Gravitino, and the great community support. So to share more details about the IRC adoption at Pinterest. So our setup is actually relatively simple, so which means that it is easy to manage. We have two clusters of Gravitino IRC implementations. One cluster is served for the ad hoc traffic with 5 instances, and the other have serving for the scheduled traffic with another 5 instances. They all are using High Metastore as its backend. In terms of usage, we have about 300,000 events, Gravitino events daily, and for the load table operation, the QPS is less than 1, and the duration P95 is less than 4 seconds. And for the update table, the QPS less than 1, and the duration P95 is less than 2 seconds. Then let me walk you through how we deploy and run Gravitino IRC setup at Pinterest. On the right-hand side is the architecture diagram. And then as you can see, so all the Pinterest Iceberg clients will talk to IRC, Pinterest Gravitino IRC via MTLS. This is the way we do authentication, with the clients. After the request goes to the Pinterest Gravitino IRC, it will ask a Pinterest credential vending service to get the S3 credential for all the metadata read and write operation that happens on the IRC. After it fetch the token, so IRC will talk to S3 storage for the metadata access, both read and write. And if there's any commit that needs to be made to HMS, and also there's any read to the HMS, then the IRC service will talk to the Pinterest High Meta Store service to perform the operation. Then let me also walk you through the surrounding ecosystem and setup for the IRC. So Jerry previously mentioned about auditing and also the logging. So we dump the auditing logs and the server log through Kafka, which further will be getting ingested to S3 through the ETL process. This audit logs will be made available in an offline Iceberg table for further analysis. On the same time, server log will be shipped to Kibana or OpenSearch for log browsing. In the last session, we will walk you through the future plan of both Pinterest and the Gravitino community. On the Pinterest side, we will continue to collaborate with Gravitino community on table governance, metadata operation speed-up features. In terms of storage and compute optimization, we are thinking to optimize them using the IRC stats, including commit reports and scan reports. And by leveraging IRC, we hope that the service can provide intelligent recommendation for us to tune the table by sorting, compacting, or even pruning. We also hope to monitoring the job performance with the IRC service so that we can have a close feedback loop to measure the impact of the table tuning. We are also thinking to continue to increase the adoption of Iceberg with rolling out the default table format to all the engines. Right now, the default table engine is still Hive, so by changing that, we expect to massively increase the adoption of Iceberg at the company. Then, last but not the least, we're also thinking about Iceberg library version upgrade, table version upgrade as well. Then I will hand it over to Jerry.
Yeah, for the Gravitino Iceberg race catalog feature plan, the first thing is about the, I think the very important thing is about table maintenance. And because for the Iceberg table, if we want to have both the good read and write performance, we should do some operations on the Iceberg table, like table compaction, open file removes, snapshot expiration, and something like this. But users should take care of these things. So our plan is to provide a centralized automatic solutions service for the table maintenance things. So users don't need to care more about how to optimize their Iceberg table. And the second thing is that because we provide a centralized race service for the Iceberg tables, so we can do a lot of optimizations compared to the previously what we do in the client side, like partition listing mentioned by Puchen, and metadata cache and other things. And this is easy done in the server side because it is a centralized server. So we will continue investigating on these areas to achieve a better performance for the Iceberg table. And because Gravitino Iceberg race catalog, it is a federated catalog which can support different catalog backends. And currently we support like Hive and JDBC catalog backends. We will extend to support more catalog backends like S3 catalogs and Polaris and others. And furthermore, for Iceberg race catalog, which needs to be which want to be landed into the production environment, there are a lot of other enhancements regarding to the security and authorization, access control, and others. And we will work with the community to continue do the enhancement on these areas to make sure that Gravitino Iceberg race catalog can satisfy the in production needs for the different scenarios. And also, we will have a webinar in the next week to introduce more about the details of the Gravitino Iceberg race catalog. So stay tuned. We will let you know the link and how to get it, how to check the webinar. Yeah, that's it. Okay.
Hi guys. Well, thank you so much for your session. You did get one question. So can you go into a little more detail in how you implemented the custom metadata for Delta partitions?
Yeah, I'm happy to walk you through. Let me go to the slides. Okay, so this is the way we implement. Every time, if you look into the Iceberg code base, right, we are, and when you performing the write, there's already a supported metadata property called change number of change partition. So what we did is do following a very similar line of execution, but additionally, we are just like instead of like counting the number of partition, we are just writing the changed partition in the snapshot metadata. Hope that helps.
Perfect. Thank you. Another question is, how is Gravitino aligning with S3 tables?
I think the basic things that what we achieve to support S3 table is that, yeah, this is a feature plan. So the first thing is that S3 table is Iceberg table. So it follows Iceberg spec. So it can be read and write through the S3 path directly. And another add-on thing is that S3, they build their S3 catalog. That is an in-house service. And so with this S3 catalog, a user can use a namespace to query the S3 table. And with Gravitino, because we support, we build a framework which can support pluggable catalog. So S3 catalog can be one of the implementation under the REST catalog. Then we can use the REST Iceberg REST spec APIs to talk with the S3 table. Yeah.
Awesome. What are you using the tags on the catalog and the schema for? Where do you store the tags?
Yeah. Yeah, we can label on the different entities like catalog schema tables, and we store the tags in our Gravitino because Gravitino has a database, and we will store the tags with the related entities in the Gravitino, so user can query based on tag to query based on tags to see the entities related to that tag to do the data, to do the classification, something like this. Yeah.
Awesome. Can you expand on the security and access control enhancements? What security problem are you aiming to solve?
Okay, so I think we provide a production ready authentication and authorization solutions for the for a Iceberg race catalog and for the authentications, and because user need to know who is who, right? So we provide a different authentication solutions like OAuth to Kerberos, Benego, and others. So when the client connect to the Iceberg race catalog, they should have the user information with their request. Then the server can know who is who, and then can with this who is who, then we can do the access control things based on who has the privileges to query on the tables. So authentication is mainly for know who is who, and in the next page we also provide a access control things based on our role-based access control model. So we can grant the users with the privileges on the specific Iceberg tables. Then when user access the table, then we will check if the user has permissions to read or write the table, and then we will return the result to the users. If the user doesn't have the permission, then we will reject the metadata operations, something like this. So this is I think the general solutions for the security and access control things. Yeah.
Awesome. Well, thank you guys so much again. That's all we have time for. So as a reminder, all sessions will be available on demand within 1 hour of the session ending. And up next in track 1, we will have scaling data workflows with Apache Iceberg, best practices for performance and reliability presented from the team at Meta. So we'll see you there. And again, have a great rest of your day. And thank you all for tuning in. Bye.